Please continue.
Yes, ma'am.
Abdul Hakim, you carry the PPT.
Yes. Is my screen visible, sir?
Tell me first of all the title, proper
Hello.
of title.
Secure and energy aware routing protocol using a heat clustering approach in WSN, wireless sensor network. Is my screen visible, sir?
Yes, it is visible. Go to the first slide.
Go to first slide about title.
Yeah.
Just 1 minute wait. Secure and energy.
Shall I start, sir? Yes. So here I am presenting the paper on secure and energy aware routing protocol using heat clustering approach in WSN. Is my voice audible, ma'am?
Yeah, okay.
Yeah. So here, basically, as we know, in hierarchical routing protocols, there are a good number of protocols starting from leech and all. Low energy adaptive clustering hierarchy, which is one of the benchmark protocol available as part of NS2 as well for research people to simulate their respective work and all. So here in this particular work, what we did is, of course, leech itself is having a phenomena or a kind of advantage to increase the network lifetime rather by retaining the energy consumption to a larger extent by aggregating the data and duplicating if probably redundancy is being encountered across particular cluster members rather, right? So which is said to be the simple data processing at every cluster head. So that itself is in the name itself you can see energy adaptive. So but then here in this particular paper we are trying to enhance even reach a bit more by using heat approach. In heat actually a smart grid approach will be employed where the virtual grids are going to be formed basically. So here, of course, intra and inter cluster uh, communication is going to happen. So because of which the energy consumption will be reduced to larger extent, and it as well, not only help in providing the good kind of energy efficiency in lower density, but as well in higher density regions also it probably helps us out. So here, actually, what we did in this particular paper, we've combined, leech, TDP, and then heat concept. So together, it's a kind of hybrid protocol. The other way I can say. So it's a hybrid protocol of these three mixture rather, right? Leech, TDP, and heat. So with leech and heat, we are trying to take the energy as a energy efficiency to be improved rather, right? And the TDP probably we are taking its concept here in order to make the data secure, because as we know WSN basically is a collection of sensor nodes that are dispersed across an unattended hostile environment where the sensors can be tampered or probably can be damaged due to some physical obstacle or by any intruder as well rather, right? And not only that but as well the data which is going to be transmitted across these particular sensor nodes as well can be intercepted by the attackers. There are different kind of attacks probably you may find in WSN like sinkhole, black hole, selective forwarding, gray hole, and probably CBL attack and all kind of thing. So hello world and all wormhole. So keeping in view of all these kind of attacks to prevent from TDP is being here used. So TDP trust distance protocol. Here we have used certain parameters used on this basic on this particular parametric values. Here we are trying to distinguish the trusted nodes from the untrusted, so that the untrusted nodes can be isolated from the network from being participated in the communication rather, right? So here and then the path is going to be set, which is going to be an optimal one keeping in view of redundancy of data as well being removed while the data is being aggregated at any cluster head before being transmitted to the sink. So this is all about my work actually, sir. We can here probably see the different uh, topics under contents: introduction, literature survey, proposed system, implementation, conclusion. So let me start with introduction, as I have given you a brief introduction before itself. So here we are using TDP and heat, right? So from TDP we are trying to derive the trust properties in order to isolate the untrusted nodes from the trusted, rather, right? And probably heat is helping us out in enhancing the energy efficiency to the leach, existing leach, right? So there are a couple of references that I've seen in the recent time, like trust-based secure energy efficient routing protocol, published in 2022, where he is calculating the trust based on direct, indirect, and energy trust. So there are three parameters he has adopted in order to calculate the trust. Uh, Fine. And if you probably look at TDP, the one which we have employed here, which we are taking here to implement our own. It basically has four steps. One is the topology management, link quality appraisal, grading, and selection of path. So with these above four steps, the trustworthy secure path is going to be selected for the data transmission. The performance here metrics are calculated in terms of delay, throughput, packet loss, and overhead control overhead. And a review on a review study on various hierarchical routing protocol in wireless design published in 2016. When it is also one kind of hierarchical routing to select the best hop neighbor, at least to the best, which will probably leads the network life time to be elongated. Study on various clustering approach published in 2015, where to form the clusters he is trying to obtain the raw data information. So the raw data probably ineffective here. If it is ineffective, then probably the clustering approaches that are going to be used are here mentioned actually. A hybrid energy efficient distributed clustering approach for ad hoc sensor is another is another paper which is published in 2004, which is proposing the least protocol with k-means clustering. So here k-means one of the classification algorithm of machine learning he is using in order to form the clusters actually, right? The performance of metric here shown, where he has improved the network lifetime, increased by 40%, energy consumption decreased by 38%, and data packet received increased by 60%. Another one, a distributed energy efficiency and gathering, data gathering and aggregation protocol for wireless sensor node published in 2005. The enhancement of the same is, of course, the heat, rather, right? So that was proposed with the energy efficient hybrid cluster protocol. The performance was more efficient, about 35% more than existing leach actually. So the proposed system, as I said, is a hierarchical in nature and a combination of these three: leach, TDP, and heat. In leach, basically, what happens? There are two phases. You find, the study phase and the setup phase. In setup phase, you form the clusters. The clusters which are being formed in basically leach. You take the distance as one of the metric. Are the energy, of course, right? Over the energy. So using this, the clusters are going to be formed in leach. Once the setup phase is done, then steady phase. In steady phase, the communication is going to happen using TDMA and CDMA. Intra-cluster communication is going to happen with TDMA, time division multiplex, multiple access, and then across the clusters, of course, the CDMA technique, code division multiple access is going to be used, rather, right? So here, if you probably see the intra-cluster communication as going to happen based on the TDMA. So every node is going to be allotted with some kind of time, actually time frame. So within that time frame, it has to communicate with the cluster head. If you cannot able to do, then until it gets next turn or probably next simulation, it has to wait, rather, right? But in heat, if you probably see, we are going with instead of time frame, we are going with energy actually, right? So this is the difference. I'm just giving you a small difference before I'm entering into how the heat is being different from our leach algorithm, right? So the two different phases here you can see are illustrated with the help of small diagrams here. In the setup phase, you can see where the clusters are being formed based on, as I said, distance and energy. And the in steady phase, the communication is going to happen across the clusters and the base station, rather, right? So across the cluster, in the sense intercluster communication will happen with the help of CDM, rather, right? So in TDP, if you probably see, we have about four phases is seen as we have seen. So one is the first one is, you can see the clusters are going to be formed with based on the Euclidean distance. So and then the grading is going to be done. Then the transistors nodes are going to be separated. Then the communication is going to happen with the help of a secure path which is being selected, rather, right, across this trusted nodes. So this is how the TDP architecture. You can see the topology management. As you can see, the grouping of nodes is once done. The Euclidean distance is going to be calculated across all this particular node, and then the clusters are going to be formed based on the node proximity and the residual energy. Here, energy also we are taking into consideration because we are working with heat, right? Rather, right? So we are taking node proximity and the residual energy. There are two parameters using which the classes are going to be formed here. Then the grading. Second part is grading. So here you are trying to separate the distance node from the trust node by
Okay,
setting up
okay.
the threshold value of about 6 over here. Then the path is going to be selected. A secure path is going to be selected across this particular cluster node. The packet format is mentioned here: header, information, and trailer. You can see here, and the heat algorithm you probably see. Initially, data depends on the carrier length, and the states are constructed according to the heat algorithm. In the next phase, the clustering is done based on the waiting time. Next step in the clusters will be rotated based on the residue. See, the third step here, the cluster heads are going to be rotated. They are not going to be same. Of course, in leach also it's going to happen periodically, because the cluster head generally being selected with the highest energy, and since it is having the responsibility to transmit the entire data which has been aggregated across the cluster to forward it to its next cluster head or base station, it drains out much earlier than compared to other nodes. So there is a possibility that it may get drained out and then go dead as well. So the responsibility, the role and responsibility of the cluster head has to be taken out by someone else. It means this cluster head is going to be replaced by some node across this particular same cluster itself. So which is of course in leach also being done by periodically electing the cluster heads based on formula where the energy is going to be taken as a parameter to see that which when a particular cluster head is going beyond the threshold, that will be replaced with a new node as a cluster head, rather, right? So similarly here as well in heat, what happens is this node across this cluster going to be adopted or elected as a cluster head periodically based on node proximity and out degree, as I said. So the out degrees also will be taken into consideration, and of course distance, then the residual energy, right? So in the step four,
Okay.
yes, sir, yes,
Go
sir.
go to next slide.
Yes, yes, sir. So in this particular,
Implemented.
this project is implemented in NS2 actually. So this is the simulation parameter which we have taken now to implement NS 2.3.2. So the result that we have obtained after we have executed this particular system, we can see that these are the some of the simulation
Okay.
NAM windows. So the
Okay. Go
throughput of
to
yeah.
conclusion and future work.
Yes, yes. I'll just come to the results here. So here, when these three protocols are being compared, TDP, leach, and heat. Heat is our proposed one. With respect to different parameters like average delay, packet delivery, number of nodes, residual energy, rounds, and throughput, we can see heat is performing much better than compared to TDP and leach. So here, heat the other way around. I'm just saying that we have combined the features of both TDP and leach and enhanced the protocol with from both the aspects, energy and as well the security. I'm here concluding that heat is presenting a good energy efficient and data gathering protocol, and as well removing the duplication data, because when the data is being aggregated, the cluster heads pre-processing is going to be done. that pre-processing will lead to remove the duplication of data from the cluster head before being transmitted to the forwarding cluster head, or it could be the base station rather, right? So that's another thing. And then it's a supplement to TDP, we can say, which is covering the region to reduce the number of working nodes, and it is not only performing better in lower density but as well in higher density. It is performing better, and lifespan of the network is also been increased as the energy parameter is taken into consideration while electing the cluster heads.
Okay, thank you very much.
Thank you very much, sir. Thank you, sir.
Then one more question I'm asking.
Yes, sir.
How to calculate energy formula?
Yeah, energy from previous to present communication, sir.
Why using the Euclidean distance?
Yeah, distance for the node proximity is one of the parameter which we have adopted here in order to form the clusters. So in order to know the proximity, basically sensor nodes work with communication range. They have some limit for communication range, so they cannot go beyond. So how long it can sense, probably the other nodes, that will be the distance, of course, rather, right, sir?
What the software language used?
NS2,
Software tool.
it's a tool, sir. Network Simulator 2.3.2 is used, sir.
Uh, uh, why used the heat algorithm? Why
Huh.
in this paper?
Yeah, in this paper, actually, our intention is to improve the energy and as well the security with the existing algorithm that we have taken, like TDP and leech. So in heat, what is happening? One thing is, of course, distance is one thing, not proximity. Energy, residual energy is another parameter which we are taking into consideration, and out degree is another parameter which we are taking into consideration. And intra-cluster, inter-cluster, both the communication is going to happen. Intra-cluster is among the cluster members. When probably cluster head is getting
Okay,
drained up,
okay.
then probably to find out which can probably take its role and all. So and then forward the same to the base station. Across the cluster head and the base station, we have inter-cluster communication. So
Uh,
intercluster, intra-cluster, duplication of removal of redundancy data and all are making the protocol more energy efficient and secure enough, sir.
uh, data set size, how much it cost? Data
Sir,
set size.
data sets, no, sir, we will not use any data sets here.
Okay, thank you. Thank you. Okay.
Thank you, sir.
Audience, any question?